So let's talk about what it means. First of all, the R squared, and this is something you do get taught in year 13, but we're just going to go over it. And in fact, it's very easy to misinterpret, and for the last 2 years it was misinterpreted. When you fit the line, you get the slope for the data, and the data is a sample of the population, and so you want to know how useful it is. So what you want to know is how well does the x variable explain the response variable. So if we had, let's have a look, say here, we wanted to predict how much debt a person has, would we do it better if we know how much television they watch than if we don't know how much television they watch? Okay, now if we didn't know, we would just go for the average. That would be the best thing to predict. So around here, this is where the average will be about 100 and something or other, about 120. That's what we'd predict. But with this slope, you can see that these dots actually do go with the slope. So with these ones, we're actually going to predict better. But what we want to know is, out of the variation in these dots, that's the total variation in consumer debt, what percentage of that is being explained by the line? Now, we come back again to lecture in the first lecture of the term where we talked about variation, and we talked about natural variation, we talked about explainable variation, sample variation or sample error, and bias. And explainable variation is what we're talking about here. There's a lot of variation in the data, but we can actually explain some of it by saying that it's due to the number of hours of television watched. So this is where we're coming from with explainable variation. So what the R squared tells us is what percentage of the variation in Y is explained by X, and it's known as the coefficient of determination. So if we look at this, our R squared value back on the previous page was 31%, or was given as 0.30 something or other. Where's it gone? So back here, 0.306, so we round that up to 31. So 31% of the variation in household debt. Another way of thinking about it, because it does give you an idea of how useful this whole thing is that 69% of the variation, that's 100 minus 31, in household debt is not explained by the number of hours of television watched. So somebody could say, oh look, I've just shown that hours of television watched really makes a big difference to the amount of debt. And you can say, well yes, it explains 31% of the variation, but there's still another 70% pretty much that is not being explained by it. So that's where the R squared is useful. I mean, quite often you get quite small R squareds, but it can still be significant. And that's something I'm going to talk about a little bit later. R squared is the square of R, and okay, sometimes the variables, sometimes they're called explanatory and response, sometimes they're called independent and dependent. I tend to, because of years of practice, I call them independent and dependent, but I think actually explanatory and response are quite good names for them too.